Wi-Fi technology is changing fast. Wave 2 of 802.11ac is now rolling out on new access points, right? How time flies. 802.11b was cool, but then G was even cooler, and then there was AG, and N made all of that seem really slow until AC. Well, AC's been way better than N for most of us, because it's actually been rolling out in waves. So if you have it right now, you probably have Wave 1. Well, Wave 2 is a Wi-Fi milestone, as it can now outperform wired Ethernet. But it also has a few ripples that need to be understood, so let's take a closer look. Because just matching the AC specs does not mean matching the promised performance. Your unique conditions will make a difference, certainly, but even before that, look closely at what you're getting, because a sloppy implementation of this spec on the vendor side could be worse than just sticking with older models. Well, both waves of 802.11ac offer improvements by being wider, tighter, and cleaner. Wider, with 80 megahertz channel widths, double that of 11n. And now there are even options for 160 megahertz and larger frames that can share radio resources between channels of different sizes. Well, 11ac also dramatically increases the data packed into each RF transmission through tighter modulation using 256 cam. And thankfully, the mandate for being in the 5 gigahertz band also results in a much cleaner interference environment. I think we've gotten everything we can out of 2.4, so let's leave that to the cordless phones, the microwaves, and the older clients. Well, the most interesting technology within 802.11ac Wave 2 is multi-user MIMO, which offers much increased efficiency over single-user MIMO. Now, multiple client devices can receive data simultaneously through MU-MIMO and beamforming. Well, beamforming concentrates and steers a radio towards a specific client instead of throwing a signal out in all directions hoping that it will hit something. Beamforming with 802.11ac is explicit, which requires more frequent feedback between the AP and the client using an extended version of the channel sounding process to alter signal phasing and get a higher effective power level. Well, it's also more efficient with how it comes on and off the air, which can effectively leave the RF open and more available. Now, this does not actually make the network faster. It just feels faster because it's so much more efficient. Well, Cisco engineers have been given a steady improvements on beamforming since 2008 with ClientLink, and there's other vendors that have their own versions, but 802.11ac now narrows all these methods to one. So why is this better? Well, it helps to first understand single-user MIMO. SU-MIMO debuted back with 802.11n using multiple antennas to send and receive more than one data signal on the same radio channel. This was in response to natural interference from signals that would bounce off objects. These reflections would arrive at different times and angles, which would force slower bandwidth. Well, SU-MIMO was able to provide a more robust link by ironically exploiting this multipath issue through the collective signal measured across the antennas. Well, it also operates in a serial fashion where each client device has to wait its turn, which means that all these mobile devices that we're carrying will sometimes cause a little strain. A SU-MIMO AP can run out of time trying to sequentially rotate through each client, causing them all to get lower bandwidth service. Well, multi-user MIMO and 802.11ac Wave 2 offers this parallel service. By transmitting to multiple clients simultaneously, the access point can make full use of its gigabit capacity. Well, MU-MIMO also provides better support for single-stream clients, all these mobile devices. This reason alone may be why you would put these new models on your shopping list. Well, there's a tremendous amount of engineering when beamforming to multiple clients at the same time, especially now that so many are moving around. It is a required element within multi-user MIMO and far more challenging, as it really depends on how well each AP does the math. It may also be one of the most difficult features for vendors to get right, so it pays to tread carefully. 6.93 gigabits per second is the published possibility, which is a 1,500% gain over 11n. Now, granted, these may not be the numbers that you see when you deploy, but given all these improvements, wider channels at 5 gigahertz, tighter modulation schemes, and more efficiency with MU-MIMO, it all adds up.